Hey folks, welcome to my channel Number Pen. So there we have the problem on our screen. Find the derivative of the following function with respect to the corresponding independent variable. So the function that we have is cosecant x cot x, right? So it looks like it's a product of two functions, and we would like to apply the product rule of differentiation. But before that, we notice that we have two trigonometric functions whose derivatives are yet to be figured out using first principles, right? Because we worked out sine x using first principles, we worked out cos x using first principles, we worked out tan x using the quotient rule in differentiation. And if you've not seen any of those, I'm going to put up a link to those videos in the description. And we have now cosecant x and cot x, right? And let's solve for cosecant x, right? So let me pick up my f of x equals cosecant of x, or let me call it u, right? My u is cosecant of x, right? And I'm going to solve this using, which one do I use? For a change, I'm going to use first principles for cot x, and I'm going to use the quotient rule for cosecant x, right? And how do we use the quotient rule? Because we know what is d by dx of sine x, I can rewrite my cosecant x as 1 by sine x, right? So what is my u dashed here? My u dashed will be, I need to square the denominator, right? And why am I doing this? Because I'm applying the quotient rule. I square the denominator. So I have a sine squared x. And then I apply the quotient rule, sine x into d by dx of what I have in the numerator, right? So, but d by dx of 1 is a 0 minus 1 into d by dx of what I have in the denominator, which is a cos x, right? So, my first part of the numerator is a sin x into 0, which is 0. And then my second part is minus cos x because it is a minus 1 into cos x, right? So minus cos x divided by sine square x, right? And what is that? It is nothing but minus of cosecant x into cot x, right? Why is that? Because my cos x by sine x is cot x, and then into 1 by sine x is cosecant x, right? So I have a cot x out here, right? So there we have our u dashed, okay, using quotient rule of differentiation. And now I'm going to move ahead and solve for cot x, right? I can use the quotient rule again and quickly solve for cot x, but imagine you get a problem in the exam to solve cot x using first principles, then you cannot apply the quotient rule. So I want you to get hands-on application of first principle to various types of functions, right? So in that regard, let's do cot x using first principles, right? So let me call my equation. What is my v? My v is cot x, right? And let's move to the next line. What is my v dashed? My v dashed is nothing but, using first principles, I got to write this out now. I call out my limits. My limit is h tending to 0, v of x plus h minus v of x, v of x plus h minus v of x divided by h, right? And what is my v of x plus h? My v of x plus h is nothing but cot of x plus h. And what is my v of x? It is cot x divided by h. Remember, folks, we still have a limit out here. I'm going to rewrite this right in the next line My cot is nothing but cos by sine, right? So I'm going to rewrite that in that fashion. So let's write out what is our v dashed in terms of cos x and sin x, right? And this is a good thing for all of us to do, right? So whenever you find it a little complicated to simplify, it is always better to express some terms in terms of cos x and sin x, because those are the basic trigonometric functions that we all know, and it might be helpful to represent functions in terms of sine and cos and see if they are further simplifiable, if at all you're finding it difficult to simplify it otherwise, right? So my cot is sine x plus h 1. So my cot of x plus h is cos x plus h divided by sine of x plus h minus, what is my cot x? My cot x is nothing but cos x by sine x, right? So let me write that again. I have my h in the denominator, right? So now I can do a cross multiplication, and I can rewrite this particular expression as cos of x plus h into sine x minus sine of x plus h into cos x, right? And then I take my sine x plus h, and remember folks, I still have my h. I'm going to write this particular expression using the formula sine A cos B minus cos A sine B, right? You know which expression I'm referring to. I'm just going to highlight this. I'm highlighting the numerator, which is in green. And what is my sine A cos B minus cos A sine B? It is sine of A minus B, right? So when I write sine of A minus B, my A is x, right? And what is my b? My b is x plus h. So what is my sine of a minus b? It is sine of x minus x plus h, right? And then I retain the terms in the denominator, right? My x and x gets cancelled out within the sign. Therefore, I can rewrite this as sine of minus h, right? So which is nothing but minus sine h divided by, I have this particular expression, right? My sine x into sine of x plus h into h, right? So let's combine our sine h and h, and I'm going to open my flower bracket. Remember folks, I have a minus sign, and then I have a sine x which is independent of x, so I can pull that out, minus of sine x, and then I still have a 1 by sine of x plus h, right? That's what we have. And remember folks, we have our limits, and I'm going to apply the algebra of limits and rewrite v dash like this, right? Sin x is out of h, so I can straight away pull it out and retain it outside of limits. And then I'm going to combine the sin h by and h. Because I'm applying product rule for limits, I'm going to write this as limit h tending to 0, 1 divided by sine of x plus h, right? I think we are more or less arrived at what we want to arrive. So my minus 1 by sine x is minus of cot minus of cosecant x. right? And my limit h tending to 0, sine h by h is nothing but a 1, right? From the identity of limits. And then my limit h tending to 0, 1 by sine of x plus h. What is that? My 1 by sine of x plus h. Sine is a continuous function. And therefore, for continuous functions, limit h tending to 0, 1 by sine of x plus h, as h tends to 0 is nothing but my f of x, right? Which is nothing but my 1 by sine x, which is again a cosecant of x, right? So what is my answer for cot x, right? My answer for cot x is minus of cosecant square x, right? So that's the derivative of cot x using first principles, right? So before we go back to our equation, to our function, so we have solved cot x using first principles, and the answer is minus cosecant square x. So this is an identity which you can apply when you come across cot x in your functions, minus cosecant square x. And then we used the quotient rule to solve for cosecant x, which was minus cosecant x cot x, right? Now I'm going to go back and pick up my original function, which is cosecant x cot x, and solve for the function, right? Let's copy this here. So my f of x is cosecant x cot x. So now I know that it's a product of two functions, right? So what is my f dashed? So if my u is cosecant x, my v is cot x, my f dashed, which is d by dx of f, is nothing but d by dx of uv. From the product rule of differentiation, I can write it out as uv dashed plus vu dashed, right? Let's move to the next step. So I'm going to write what is my f dashed straight away, because we know what is our v dashed and u dashed. So my f dashed is u v dashed plus vu dashed. And what is my u? My u is cosecant x. And what is my v dashed is what we worked out using first principles. It is d by dx of cot x, which is minus cosecant square x. So let's write that. And then I have my vu dashed. What is my v? My v is cot x. What is my u dashed? We worked it out using the quotient rule of differentiation, and it was minus cosecant x cot x. Right, so let's copy that. So again, I'm going to express this in the form of sine and cos and see if it is possible to further simplify this, right? Now, what is my cosecant x into minus cosecant square x? It is nothing but minus cosecant cube x, which is nothing but minus 1 divided by sine cube of x, right? So let's write that out. Sine cube of x. Then I move to the next expression, still have a minus. And what is my cosecant x? My cosecant x is again minus of 1 by sine x into cot x is cos x by sine x the whole square, because we've got two cot x out here. So I'm going to write this as cos by sine. All that I've done is represented cosecant x and cot x in terms of sine and cos, right? So we have a sine cube x in the denominator, and let's write it as sine cube of x, and we've got a negative sign which is common to both the first part and the second part, and then I have a minus 1 plus cos square of x, right? And I don't think we can further simplify this. So let's leave it out like this in the form of sine and cos, and we are sure that this is not possible to simplify further, right? So there we have the final answer with us. So the final answer for cosecant x cot x is minus of 1 plus cos square x divided by sine cube of x, right? So I hope you found this content useful. Please do subscribe to my channel and support. Thank you.